All right, guys, welcome everyone to a Wireshark meeting. So this meeting is obviously going to be about Wireshark. And for those of you not familiar with what Wireshark is, it is a program that allows us to analyze network packets. Uh, Specifically, you can see individual packet by packet data going over your network. So if you need that level of granularity, Wireshark allows you to do that. I'm going to be working inside of a Kali Linux environment today. And the reason why I'm working inside of a Kali Linux environment is because this is running inside of a virtual machine, and the whole entire purpose of virtual machines is for isolation. So we're able to get network isolation. So if I were to run, Wireshark inside of here, and I were to browse the internet on my Windows PC, it would not pick up any of the network activity because we're isolated in this environment. But yeah. So if you have Kali Linux right now and you have it open, you can really just access Wireshark because it's installed already by default. You can do it either by typing Wireshark into the search menu right here and then run Wireshark that way, or you can be cool and then do sudo Wireshark from the terminal like that. Oh my god. There we go. And then yeah, boom, you have Wireshark right here. If you're not on Kali Linux, you can just as easily install Wireshark at wireshark.org and just follow the installation process, or sudo apt-get, whatever your preference is. It's a really easy installation nonetheless. But this is Wireshark right here. It looks pretty clean and simple on the surface, but it can actually do a lot of things. The amount of things that this program can do, it would take more than just one lecture to fully explain everything that it does. And I don't even know everything that it fully does because it's just so complicated and it can do a lot for you. But we can get through the basics. And so yeah, let's just start going into it. So this is the what you see when you open Wireshark. And what you'll notice right here is we're going to have different network cards that we can capture activity from. Specifically, I'm going to be capturing from ETH0. This is my network card on my PC, and I'm connected through Ethernet. But if I open a new terminal here and we type ifconfig, sudo ifconfig, my bad. I don't know why it does that. You can see that we have two network cards on this virtual machine that we can capture network data from. So I have ETH0. This is what I can capture from. This is literally where all my network data goes through. And then we also have this other one here. This is a virtual network card. It's a loopback. It's not really for our intensive purposes, not what we want to be focusing on. But loopback is essentially a way for your computer to talk to itself. So that's interesting. But I'm just going to be focusing on ETH0 since that's really where the majority of our packets are going to be routed through anyway. So yeah, I'm going to go ahead and highlight ETH0, and I'm going to click this blue button on top left that says start capturing packets. Oh, and notice how there's a solid horizontal line right here. This basically means we can get like a histogram view of just, any network activity. Obviously, we're not browsing any internet, activity right now. So this is basically just a clear line. Anyway, we can click start capturing packets, and we don't get anything right now. But like, let's suppose, I open up Firefox right here, and let's see here. Let's go to google.com, and then you can see the packets that are being sent from my computer to, and outbound to Google servers, retrieving all this data right here. And so you can see all the packets that we received. In the span of just 15 seconds, 730 individual packets were received and sent. Let's go to our favorite websites, Reddit. I love Reddit. Go on Reddit, see what's going on here. Cool, cool, cool. Uh, let's go to YouTube. Cool. And I'm gonna open up Discord as well. And I just want to give you a sense of just how much data is flowing through a network. Even when it doesn't look like a lot is going on. But let's see. If I go to the Berg CyberSec right here, this is our Discord right here, and I can type something right here. Hi everyone. And that packet would have shown up somewhere here. I don't know exactly where it's at, but it would have shown some up somewhere here. Um, but yeah, so I'm gonna go and quit Discord, and let's go and start watching a YouTube video. Preferably nothing related to politics. This one seems very interesting. Bear sits next to a guy, and of course you have an advertisement. Right now, we are roughly 87 seconds in, and 8,000 packets have been captured. What a long ad. And we can capture the packets being streamed for this video right here, all done through TCP, through the TCP protocol. Anyway, that's enough. I'll go and close this right here. And once we're done capturing all of this network data, we can go ahead and click this big red button that says stop capturing packets. And yeah, and so now we have a entire list of network packets that we have just captured right here. Um, Now, the next logical question we can ask ourselves is, what does all of this mean? And that's a very good question. So I'm going to go and move this down right here. Move this down just to give us more view of the network packets. And I guess I should go ahead and start off by, explaining what do we see here. So one thing that might stand out to you is the colors. And these colors definitely do mean something. These colors are mostly, to identify the type of packet that is being sent. And we can see a legend of the colors. So if you click, oh, I did that kind of fast, click view, coloring rules, you can see what these different colors mean. Um, you can see that the majority of the colors that we have here is kind of like in this light purple right here, which are indicative of a TCP packet. So that's this one right here. And then we also have some light blue colors right here, which is indicative of a UDP packet. And then, once in a while, you'll get some HTTP packets as well. And then, you might come across like this really scary one right here that's in all red. Usually it's like a checksum error or, some type of error that wasn't accounted for. Or maybe like it says TCP reset right here or SCTP, which is an abort. Um, so yeah, we can categorize the different types of packets that we are analyzing on the network, which is pretty handful or, pretty helpful uh, to help us, not get drowned in a sea of information, right? Um, yeah. So I think the next thing I wanted to go over is, how does TCP work? Really, the more common types of packets you'll be seeing is TCP packets and UDP packets as well. I'm going to go ahead and give a brief explanation because you probably have heard those words around, TCP protocol and a UDP protocol. Like, what is that? I feel like that should be explained. I'm going to give a very simple explanation as to what TCP and UDP is. But basically, a TCP packet is essentially, or the TCP protocol, I should say, is really just a way for packets to communicate with a server. It's like a protocol, it's just like a set of rules that packets have to follow. So anytime you see TCP packets, just know that what's happening is a connection is being made with a server and a client. And this is a three-step process known as a three-way handshake. And so TCP packets, they initially go through this synchronized packet. So the TCP says, hey, let's synchronize with the server. And then the server says, okay, I acknowledge you want to synchronize with me. So let's synchronize. And then the TCP packet says, okay, I acknowledge that you want to connect with me as well. And then he sends that to the server. And then the server says, okay, I acknowledge that you acknowledge that both of us are connecting. And so what this does is it creates a connection, a very reliable connection with TCP. So it's usually you'll see TCP packets when you need again like a reliable source of information coming in. So with YouTube streaming, you want a reliable source of packets coming in. You don't want to have like packets coming in and then some missing, some dropping, some being modified. You want a really stable, tight knit connection between the client and the server, and that's what TCP is for. TCP enables this really reliable way of making sure that packets get from the client to the server in a seamless manner. Um, so yeah, TCP, it's really secure. Or I don't want to say secure in the sense of like, it's encrypted and it can't be hacked, but secure meaning like it's a really strong relationship between the server and the client, and the network data is, it's pretty reliable. Um, and the other type of packet that you'll see really often is a UDP packet. So if I bring up an image of, UDP, that is TCP right here. A UDP packet is really different from a TCP packet in the sense that UDP, it's it's extremely direct. So with the TCP packet, it's really just, established that we have this relationship with the server, making sure that we do this three-step process of synchronizing, acknowledging, making sure there's a connection. UDP packet, on the other hand, we just, straight away send it, give it an IP address and a port, and just send it. We don't know if it makes it. We don't know if anything is coming back. We just want to send data. And typically, you'll see UDP packets used in things like video games. UDP pack. So I mean, I play CS:GO all the time, and so it uses UDP packets to really lower the latency of how fast network data is being transferred. So UDP is really fast, but at the same time, it's not reliable because you don't know if the server actually received the packet. You don't know if you're going to get anything in return. TCP, on the other hand, it is extremely reliable, but again, because of this three-step process and constantly reassuring that we are, having a really reliable connection with the server, it can be quite slow and introduce latency. So I just wanted to go over TCP and UDP for those of you who were not familiar with what this means. And again, TCP, it's highlighted in this light purple color right here, and you'll see UDP packets, highlighted in a light blue color as well. Um, so yeah, that's really just the basic differencing between TCP and UDP packets. The next thing I wanted to go over with is something that would be pretty interesting to you. It's something called promiscuous mode. And promiscuous, it's a funny name, but you'll see how it's quite fitting. So if I click up here into capture settings right here, it brings up this window right here. And you can see that there's a little check mark box right here. And I encourage you to check it because it does really cool things. Promiscuous mode, essentially, it allows you to capture data not only being transferred between your computer and, a server or router, but it also allows you to capture data from other devices on the network, hence the name promiscuous. So we're able to capture data that is being transferred, on other devices on the network, other than just our own machine. Now, I'm in a virtual box environment, so all of the network data is isolated in this environment. There are no other devices on here. I'm in a virtual machine. So, checking and unchecking promiscuous mode doesn't really make a difference for me. But I just wanted to point that out in case you wanted to capture data from other devices on the network. You can go ahead and check promiscuous mode right here. Okay, cool. And yeah. So now I think the next thing is I'm going to go over is how do we, start filtering through all this data and start analyzing it, right? Because you have all these packets right here, but how do we make any sense of it? And let's say we have something specific in mind that we want to find. How do we filter for it? How do we, really narrow down what it is that we're searching for? And there's a way to do that. Uh, on the top right here, it says apply a display filter. And that's one thing we can do. So if I wanted to only filter out or only filter for TCP packets, I can type TCP and notice that it's in light green, meaning that it's a good filter. It's a good filter command, no typos, no syntax errors. Press enter, and all we get in return now is just TCP packets right here. So all of these are related to TCP. Cool. I can go ahead and type UDP. And now all of the packets here are, through the UDP protocol. It shows DNS, but someone unmuted. You have a question?
Yeah, why is it DNS under UDP?
That is a good question. I I I don't know the exact answer to that. My intuition tells me that UDP packets are in somehow, related to DNS. I think it's because when you go through the domain name system and you're sending packets to the domain name system, it's done usually through UDP. I'm not sure why it shows up as DNS. If
Uh,
someone wants to give me an accurate
it's
answer, how
I
does that
I
work?
can give you something here. It's
Same.
it's a lot lighter to run than TCP, and you don't need to have. The only reason you'd run a TCP connection is if you needed to create a connection that cannot drop, right? That has error checking and has all of that. You don't need that for DNS. It's a quick packet. If it's bad, you just get a new one.
Actually,
And
DNS
it's a
can
lot
do both.
lighter. Yeah, you can do it. The new DNS version, it's called DNSSEC. It uses TCP and it uses secure connections, so SSL. So you'll start seeing that more frequently. But you tend to use UDP because it is quicker and it's less resource intensive than TCP is.
Yeah. I mean, yeah, that's a really good explanation. Thank you. I hope that answered your question. Yeah. One analogy I wanted to use for TCP packets, it's kind of like sending a package in real life to someone, and you have tracking updates, and you're constantly being updated, on the status of your package, whether it got there or not. And you have a return address, like what, and you have all the information with tracking. But UDP, it's kind of just like sending a package in real life with no return address, and you give it to a dude on a motorcycle, and you're like, okay, just give it to this address. I don't know if you'll make it or not, but Godspeed. And yeah, so there's a difference between another analogy. But yeah, um, let's see. To continue, so I was speaking on filtering right here, and so filtering, it's really useful, as you can quite imagine. If we do have thousands of packets to go through, we obviously do want to filter for what exactly it is that we want. There are plenty more types of filters that we can apply here. So if I type TCP, shows UDP packets, or I can type TCP, TCP and UDP, and it shows me both TCP and UDP packets. Not quite sure why it's not loading right now. Sorry, there we go. TCP or UDP. It's just a logical difference. But TCP or UDP packets, they will show up. We can also filter for things like, I don't know, HTTP packets, DNS packets. We can also filter for HTTPS packets. Now, weirdly enough, you would think that HTTP2 means, HTTPS. That is not the case. In Wireshark, you want to use TLS to filter for HTTPS packets. And so there's that. And let's say you wanted to search for a particular sequence of characters in a packet, right? So if you have something specific that you have some sort of data in mind that was sent through a packet, and you wanted to search for it, we can do that quite easily. We can say, if we're looking for a TCP packet that contains a phrase, and the phrase that I'm going to be looking for is YouTube, because we visited YouTube. So TCP space contains space YouTube. Press enter. And you can see that we do get two packets here that have some information in their data that is related to YouTube. And I'm going to bring this up right here, and we can see the packet data right here. This is literally the raw packet data that is in this packet right here. And you can see right here on the right hand side, it says youtube.com. Oh, and by default, I believe that this is shown as bytes as hexadecimal, but I prefer just to show it as bits right here. And one interesting thing to take note of is that these bits are literally just sequence of characters right here. And if you wanted to, check on your own time, but I'll actually do it right now. So you can see that these sequence of characters right here, these is a sequence of bytes, it's actually a direct correlation to what you see right here. So youtub.com. It's these sequence of bytes that if you were to convert into ASCII, it would give you youtube.com. And just to prove it, I'll pull up a really quick, I guess ASCII to binary. ASCII text to binary. There we go. Okay. And so if I type youtube.com, convert into binary values, if you were to do like a left and right comparison, you can see that it is, I opened Discord by accident. It is literally a one-to-one representation of what we're seeing here. And this really just only reinforces the idea that there's actual information being sent within these packets, and it's not just a bunch of magic. The data that you want is, at the end of the day, it comes down to ones and zeros sent over the wire. So over the wire. But yeah, you can see 0, 1, 1, 1, 1, 0, 0, 1, and it says the same sequence here, 0, 1, 1, 1, 1, 0, 0, 1. And you can just follow it along for yourself. I'm not going to do that right now because it's a bit redundant. But I thought that was just a cool, interesting thing to point out. Cool. So we can filter for specific kinds of data, as you can see right here, if we wanted to look for more things. More commonly, you might also want to do another type of filter search for, IP.address. And I believe that the default one here is just packets. This is my IP address right here. So any packets related to my IP address right here, yeah, it will return it. So this could be useful if you're really just concerned with, a specific IP address right here. You can also filter for a specific source. So IP.src is equal to, and then you can literally type in a specific source. I guess we'll go ahead and just, do my own right here. 10.0. Oh, I don't think that's mine. Yeah. So these are all of the IP packets coming from this source right here. And similarly, you could also do a destination, see where a packet is being received. So instead of looking for the source, we can actually look for the destinations or packets being delivered to this IP right here. And now we can see in the destination column, it's the same IP that we entered here, but these are packets that have been sent to this place right here. And so this could come in handy if you are really just looking to narrow down, where it is that packets are being sent to. You have an IP in mind. Yeah. Another really interesting one that you might use is http.request. For those of you not familiar with the HTTP protocol, to really just give a simple explanation, pretty straightforward, there is a GET request. If you wanted to get information from a web server or you want to submit information to a web server, that'd be a POST request. That would be here in http.request, right? If we wanted to search for a particular method that was used, so http.request.method is equal to, and in all caps, in quotes, get. Looks like we don't have any here. Post method, filter like that. So it looks like we did make a few post methods to some servers, I guess. We can analyze the data. If I had to take a guess, let's see here. Interesting. It was most likely a website that we were visiting. You can also double click on the packet just to give you a full screen view of the individual packet. Looks like just HTML. I'm not quite sure what packet. Yeah, I'm not sure what data was being transferred here, but I'm assuming that this is just data being sent to the server as as a parameters, saying what type of client are we? So we're visiting from a Mozilla browser and we're using Linux. So yeah, just general metadata that's being sent to the server. Cool. You can also filter by port. So if you have a particular port in mind, we can do TCP. Let's say you're analyzing TCP packets and you look at a specific port. So we can do TCP.port is equal to. And then one thing to keep in mind, it's a good note just to make in your head. HTTP protocols use port 80. So this is generally where you see HTTP packets being routed through. It'll be routed through port 80. And HTTPS protocols are routed through more commonly port 443. And so there's that right here. And so this really filters our packets down by port. Cool. Next thing I want to go over is the statistics tab. There are a lot of statistics that you could generate here, but I think, I don't know what your general, more specific purpose is for the statistics you want to analyze, but I think one of the more interesting ones to look at is just, where are the majority of the packets being sent to? So under the statistics tab, I'm going to click IPv4 statistics and click destinations and ports. And this shows me, just where are the majority of the packets being routed to. So I can sort this by count from ascending to descending. Cool. And we can see that, to this specific IP address, there were a lot of packets being transferred to and from. 5,383 packets right here. The next IP address right here, 839 packets. And one thing that you could do is, obviously we don't know who are these people off the top of our head. So in the terminal, we can do who is, who is this IP address right here. So I'm going to choose, I guess, let's go for this one right here. Like, who is this packet? Who is this IP address that received 645 packets or sent 645 packets? So we can type who is 216.58.194.118. Press enter. Who is this right here? Oh, it looks like it's Google right here. This is Google with this IP address right here. Let's see. Who is the next IP address in this list right here? So this one right here. Let's clear this. Who is 209.85.231.203? Press enter. It looks like it's also Google, and I'm just looking right here. And let's just do one more, just just for all fun and purposes. Let's see here. Who is 172.217.9.142? Looks like it's also Google. And quite interesting that a lot of packets are being sent to Google. Actually, not that interesting, given that we literally visited YouTube. But yeah, if you wanted to see, exactly what a specific IP is, you can use the whois command in your terminal just to give you more information. Oh, okay. I guess that's also one thing I could bring up about Wireshark, right? So I just accidentally closed it, but sudo Wireshark. You can actually save packet data for analysis later. So if I just start, capturing packets right now and open up Firefox and I don't know, google.com real quick. Okay, I'm done. And I wanted to save this right here. I can go ahead and save this information of packets right here onto my desktop. So I'll just say, like capture, save. And it'll be saved onto my desktop. So I can quite literally just close this right here. And I can open up Wireshark again. And we can revisit the saved packet information right here. Just for later analysis, if you wanted to just come back and revisit it, that is always there at your disposal. Yeah. I think the next thing I wanted to go over is essentially this middle pane right here. So we went over the top pane right here, and I'm just going to move this over just, not really confuse us. So we went over this top pane right here. We can go ahead and see, various information, the packet number, time, who it's from, where it's going to, the protocol, the length, which is in bytes, and the type of information in that packet right here. But I'm going to go over this middle pane right here. This is what is known as the layers of the packets. So depending on the protocol that you're using, you'll see different information here. So for TCP protocols, you see like a different stack of information being sent with that packet. For UDP protocols, you see it's a different type of information being sent with this packet. And essentially, there are different layers with packets that you can analyze right here. So yeah, if I filter out for TCP packets, we can see that we get various information. So if I quite literally just select, the very first packet that was sent, we can see where it's going from and where it is going to right here. So in this packet, we can see the MAC address of where it's coming from. So this particular packet was coming from this particular MAC address right here, Realtek EU. And if I had to assume this is my own motherboard on my computer with this MAC address, and it looks like it's being sent to another MAC address with the name PCS Compu. I'm not quite sure what this could be. It could be my router. I'm not sure. Although I know my router is Aris. I have an Aris router. But yeah. So we can see the different types of MAC addresses being sent between packets and to other packets. So if I just like cycle between all the packets in this list right here, just focusing right here, we can see the source and the destination being changed. And you can see like a communication, like a two-way street being established, a communication between a certain MAC address and another MAC address. And this is, literally them talking to each other, exchanging packets. Given this is TCP, so there's a lot of talking between different ports and different MAC addresses, which makes sense. But yeah, we can also see in the next column, or in the next row, I should say, we also have a source IP and a destination IP, but that's already given to you right here on the top. And in the next layer, we can see the port in which it's being sent to. So this is being sent from port 443. And as I've mentioned before, port 443 is usually for HTTPS protocols. So this was most likely just using the HTTPS protocol, which was TLS. And it's being sent to this port right here, 39420. Not quite sure what port. It's probably just an open port somewhere listening for information. But yeah. So that's this can get really complicated. There's a lot of information for you to analyze here. And I encourage you in your own time just to analyze your own network data and just to see, what type of information is being sent and to go through this information yourself. And, there's a lot that I can go over right here. But in the scope of this lesson, we only do have 1 hour. It would take literally forever or I could say like 15 minutes just explaining what one of these rows just means. But I just wanted to give you basically a general overview of what this means right here. Cool. And one thing, I'm just going to reset the filter. One thing that I wanted to bring up is I don't like to use the seconds of when the packets were sent. You can change the formatting of this right here, of this time column. So specifically for me, I like to view it, what time of the day was this packet sent instead of like how many seconds has it been since this packet was sent. You can do this by clicking view, and we can go ahead and click time display format right here. And we can set it to, where is it at? Time of day right here. And you can see that it changes the format of the packet, of the time column right here. So it shows you exactly what time this packet was sent. And it can give you a lot of resolution. If you wanted to change the resolution, go back to time display format, and you can just narrow it down. So keep it to hundredths of a second if that's what you want. Or you can go to, milliseconds. Or you can even go to microseconds, because packets are sent really fast. And so depending on the type of granularity that you need in your data, you can, specify, just how specific do you want to see this. Okay. So yeah, there's that information right there. Um, let's go ahead and do like a real life example. Like one might you want to use Wireshark. And so one of the examples that I wanted to show you guys today is, grabbing a username and password from packet data. It's going to be a really simple example. It's not like you'll find this if you were to just run it on like a really secure website like Google or YouTube or Facebook or something like that, because they obviously have a lot more stricter protocols and a lot more security measures. But if you're ever you know uh, doing a challenge, this might come up and this might seem applicable to what you need to do. And so I wanted to include a real world example just to show that there is actual use for this in the real world. So one of the websites that I'm going to be testing this out on is this place right here, testphp.vulnweb.com. This website right here, it's intentionally insecure, meaning that we can do a lot of things with it. It even says right here on the bottom, this is a PHP application which is intentionally vulnerable to web attacks. So we can go in and test out, Wireshark on this website and grab some specific packets and specifically login information. So I'm going to go ahead and start recapturing this right here. And I'm going to reload the website. Oh, actually, let me close Discord because, that's just going to interfere with this. So yeah, I'll start capturing again, continue without saving. We should have no packets coming through. I'm going to reset or reload the website. And so now we have packets being sent through this website. Let's go to the sign up page right here. Okay. There we go. Yeah. And I'm gonna just enter like a basic username and password. So like username, I don't know, cybersec, and then password, I don't know, test123. And what I'm going to do is I'm capturing network data being sent right now. And when I click login, it's going to submit an HTTP post request, because that is how usually these web forms work, right? You're submitting information to a server for processing. That is a post request. So when I click login, Wireshark is actually going to capture that post data information. And inside of that post, that post request, we're going to have the username and the password, and we can sniff it out with Wireshark. So I'm going to click login. Don't save. Now, obviously nothing happened because it's not a real username or password, but it was captured within Wireshark. So what I can do is stop capturing packets, and then we can filter out for the data that we want. So me knowing that the method used here was most likely a post request using, HTTP, I can type in the filter right here, http.request.method, and we want to filter for post request. And we have two packets here that were sent using the post request. And so we can go ahead and, I guess, analyze this first packet right here. We can see the type of information that was being sent right here. I don't think it's in this packet. Ah, right here. There it is. So in this second packet that was using the post request, we can see in there's a row right here called HTML form URL encoded. And so this login right here, this was using a form. So this is, of our interest. And if we go ahead and open this up, we can see that we have captured the username right here and the password. And this was just, I guess, sent in plain text, no encryption done before sending it off to the server, which is really dangerous. And, it makes sense because given that this is intentionally vulnerable to web attacks, we're able to sniff out data like this. If you were to use it like in more common websites, this would absolutely not fly through. Like it would take a really bad developer to really not account for this type of information right here. But I just wanted to give you a really quick example of when you might want to use Wireshark if you know that there's a specific vulnerability in a website. You could use Wireshark to sniff out, packets being sent. Now, keep in mind, we only were able to capture this data on this machine, on this network, and ensuring that it sent the post request. So you kind of do have to be on the machine that is sending the post request and on the network, I meant. But yeah, so we have the username and the password. Obviously, terrible, terrible security, but that was kind of expected. Yeah. So there is just one way to use Wireshark in the real world. And I think this was a rather, good surface level explanation to Wireshark. It's obviously a lot. You can do a lot with this program right here. And I'm not claiming to know everything about Wireshark in its entirety, right? But Wireshark, it does have its useful features, especially if you're analyzing malicious network activity. If you're, say, doing any defense or you're blue teaming, and you want to analyze packets to make sure that all of them are not doing any, or that all your packets are not doing anything malicious, you can use Wireshark to analyze packets. But yeah, I think this is a good introduction to Wireshark. I didn't want it's 4:07 p.m. right now. I was honestly expecting me to take a little bit longer with this introduction. I didn't really expect to kind of end this short. We do have 13 minutes left. But yeah, I encourage you to download Wireshark and just to start capturing your own network data just for your own curiosity. And what I did is I literally captured network data for 12 hours, and I was able to but I was able to capture 2 million packets worth of data just in the span of 12 hours on my own home network. So there's that you could do. But yeah, I think this concludes my meeting, my presentation on Wireshark. I'll definitely be going more into detail of Wireshark and really using it for more specific purposes and more applications. I just wanted to give you guys a basic general overview of what Wireshark is and how to use it. But yeah, I think that's it. Thank you.